everyone, this is your Kalpana here. In this video, we're going to see some problems from partial differential equations. So let's get going. So these are the problems we are going to solve today using direct integration method. Okay, let's see. First problem, solve dou z by dou x equal to 1. Okay, now here we are having dou z by dou x. Okay, now let's partially integrate it with respect to x. If we partially integrate it with respect to x, we'll treat y as constant. Okay, integrating partially with respect to x, treating y as constant. We know that whenever we use integration, we'll get an integration constant, right? Here we'll get integration constant in terms of functions of y, because here y is treated as constant. Okay, we'll take constant of integration as some function of y. Let it be, say, f of y. I'm going to take f of y as a integration constant or constant of integration. Then this becomes z equal to, here you are having 1. So integral 1 with respect to x is x, right? Or without confusion, you can just write this equation as, now integrate it, we'll get, which gives us z equal to x plus some integral constant. This is what we are writing directly without these steps. Okay, don't get confused. Here you're having dou z by dou x. By doing partial integration, we'll get z equal to x plus some constant of integration, which is f of y, an arbitrary function, right? Where f of y is an arbitrary function. Now coming to the second problem. Second one, solve dou square z by dou y square. Okay, you can write this as dou by dou y of dou z by dou y equal to 0. So consider the first one, you have dou by dou y, right? So here we'll integrate partially with respect to this y. Then we'll get dou z by dou y equal to, here you have 0, right? So you'll get some integral constant. We are integrating partially with respect to y, so we'll get a constant of integration which is in terms of x, not in terms of x, just which is in terms of function of x, we can say. So let's take it as f of x or g of x or h of x or phi of x, whatever. You can take any of these. The thing is, we should not repeat the same constant whenever we do integration. Okay, fine. Now let's take f of x as our integral constant. Now again we have dou z by dou y, right? Again integrate or integrating partially with respect to y. Okay, can just again see, we are integrating with respect to y, right? Now take some constant of integration, say g of x. Now we'll take g of x. Okay, we'll get integral f of x. Let's write directly, since it is a constant. Here we are integrating partially with respect to y, so we'll treat x as constant. Okay, treat x as constant. So you'll get constant of integration f of x or g of x or h of x or f of x, whatever. So you have constant into y plus another integral constant g of x. So if you are really good at integration, you'll know how you got y. If you are not that good at integration, just observe the things. Let's do rough work. Okay, now we know that dou square z by dou y square can be written as dou by dou y of dou z by dou y, right? Again, we can write the same thing as multiply both sides of the equation with dou y. Okay, simply. Then you'll get dou of dou z by dou y equal to 0, right? Now, if you integrate, what you'll get integral and this dou gets cancelled and you'll get dou z by dou y equal to integral 0. What? Integral 0 is 0, right? 0. We won't write 0, we know that. And here we'll get a constant of integration since we are integrating with respect to, if you take this to RHS, you'll get into dou y, right? Without confusion. Now we'll get some 0 plus, here we are integrating with respect to y, treating x as constant, right? So you'll get constant of integration in some function of x, say f of x. Again, you can write the same thing as just multiply both sides of the equation with dou y. Okay, then you'll get dou z equal to f of x into dou y. Since f of x is constant, you can write it outside the integral. Then this gives us z equal to f of x into y plus another constant of integration, which is in terms of functions of x. So we'll take it as some g of x or h of x or phi of x or whatever you want. This is how you get. Okay. If you are really confused, just check like this and write it, because most of the textbook prefer this method instead of this. This you can see in rare books, okay, but most of the textbook has this procedure, so just follow this. Fine. Now coming to the third one. Here f of x and g of x are arbitrary functions where okay. Now coming to third problem, solve dou square z by dou x square equal to sin x. We can write this as given dou square z by dou x square equal to sin x, consider as equation number 1. Now we'll write this as dou by dou x of dou z by dou x equal to sin x. Okay, first you're having dou by dou x, so we'll integrate partially with respect to x, treating y as constant. We know that whenever we do integration, we'll get a constant of integration. So now let's take one constant of integration in terms of y, I mean f of function of y, let it be f of y. Okay, this becomes dou z by dou x equal to integral sin x dou x will be minus cos x plus integral constant f of y, right? If you want, you can do rough work. Okay, don't depend on rough work, always don't depend on rough work, just try to do in this pattern. Okay, try to remember, try to solve carefully. Okay, just don't depend every time on the rough work. So now we'll write this equation as this, right? So you can write the same thing as, we'll just take both sides. Okay, you'll take or you'll multiply this equation, both sides of the equation with dou x. Then you'll get dou of dou z by dou x equal to sin x dou x, right? Now do integration. This 2 gets cancelled and you'll get dou z by dou x equal to minus cos x plus constant of integration. This is what we wrote here. Okay. Now again you have dou z by dou x. We have to integrate it partially again with respect to x, treating y as constant. Now you need a constant of integration terms of function of y, right? That it be g of y, because we have already used f of y, so now we are taking g of y, and this becomes z equal to integral minus cos x with respect to x, or partial integration of minus cos x with respect to x is minus of cos x, integral cos x is sin x, plus f of y is constant into integral dou x is x plus constant of integration g of y. So therefore z equal to minus sin x plus f of y into x plus g of y is the solution to a problem where f of y and g of y are constant of integral, what I'm saying, okay, where f of y and g of y are arbitrary functions, right? Okay, here I'll just continue the rough work also. Again, we'll write this as dou z equal to minus cos x dou x plus f of y dou x, integrating, we'll get z equal to minus integral cos x is sin x plus f of y is constant into integral dou x. Integral dou x is again x, right? So you'll get into x plus constant of integration g of y. Already we have used f of y, so here I took g of y. So this is a solution to our problem. Just do this. This is your rough work. Most of the books has this procedure. This can be seen in rare books. Okay, fine. Well, we have seen some problems from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.